All right, so we're going to look at one more example of how to calculate E0 for a cell. And we're going to use an equation we have not seen before. So we're going to do this literally from scratch. We've got CD2 plus aqueous plus Al as a solid. So cadmium 2 plus, CD2 plus solid aluminum in equilibrium with CD as a solid plus Al 3 plus aqueous. So to go about this, we have to decide what gets reduced and what gets oxidized. So if we write the reduction first, our reduction occurs with the cadmium, going from 2 plus down to 0. The oxidation number reduces from 2 to 0. So CD2 plus aqueous plus 2 electrons makes CD as a solid. Aluminum must be your oxidizing side. 0 to 3 plus. So it is oxidized. Al is a solid, making Al 3 plus 3 electrons. So now we have to balance this process. Our job here is to balance the reaction and to calculate E0 for the cell at standard conditions. So we're going to do the balancing of the reaction part first. Then we'll look up our values in the table. Now we have a 2 and a 3 in terms of how many electrons are consumed and produced. We have to make the electron count balance. And to do that, we're going to have to take both of these and multiply them. So 2 and 3, the least common multiple is 6. There's going to be a 6 electron process. That means we need to do the cadmium half reaction 3 times and the aluminum reaction twice. The 3 and the 2 here come from needing to make 2 electrons and 3 electrons balance. So when we rewrite this, reduction is now 3 CD2 plus 6 electrons, making 3 CD as a solid, and our oxidation is now 2 Al as a solid, making 2 Al 3 plus 6 electrons. Now it's charge balance, got the right number of electrons. And we balance, or we cancel what will cancel. Our 6 electrons cancel. So our balanced equation, the first part that we were supposed to come up with, what's the balanced electrochemical process? 3 CD2 pluses plus 2 Al as a solid, making 2 Al 3 plus 3 CD as a solid. So there's our balanced reaction. Then we're asked to calculate what's E0 for the cell. So we go back to our reactions. Now, just because we multiplied by a 3 and a 2 does not mean we multiply the E cells in our table. I'm going to say that one more time. Just because you multiply a half reaction does not mean you multiply the cell potentials in the table. You don't. This still occurs at the same potential, we just do it 3 times. This one occurs at the same potential, we just do it twice. Okay? So these multipliers do not multiply E0s out of the table. Again, you never do anything to the values in the table except plug them straight in. Okay? So for cadmium, that has a reduction potential, we'll look up, and the aluminum also has a reduction potential that we'll look up. So we go to our table, and we're looking for a 2 electron reduction of CD2 plus. Okay, so we just scroll down here until we find CD2 plus as a reactant, as our first reactant, and then go with it. Keep going until you find it. CD2 plus 2 electrons happens at minus 0.40 volts. So the reduction potential of CD2 plus, minus 0.40 volts, not spontaneous. So we would think of cadmium as liking to be in the ion form. It's not a spontaneous reduction. Now we look up the reduction potential for Al3+. So we find Al3+ plus 3 electrons. Scroll through the table. And they're easy to miss. Keep on looking. Okay, Al3+ plus 3 electrons moves to Al solid at minus 1.66 volts. Also, not a spontaneous reduction. That doesn't mean that there's no way for this cell to be spontaneous. Because remember, we're going to end up flipping the sign on one of these when we plug them into our equation. So E0 for the cell is E0 for the cat minus E0 of the and. Cathode minus anode. The cathode is always the reduction one, right? So in this case, E0 for the cell is minus 0.40 volts minus a minus 1.66 volts. So 0.4, flip the sign to 0.4 minus, and then minus a minus is add, so plus 1.66. So E0 for this cell is plus 1.26 volts. It's spontaneous, got a positive potential, because the participant up here that was the most negative, the least spontaneous to reduce, is the one that's getting oxidized. So this sign flips because of this negative sign right here, and we end up with a spontaneous cell. So if we hook this cell up and connect the wires, juice will flow left to right spontaneously. It's a galvanic cell. All right, made it through that one. Congratulations.